Hello dear students of plus 2 medical, non-medical and respected teachers. Today I am going to discuss the concept of radioactivity and the nature of alpha, beta and gamma rays. So first of all, what is radioactivity? Basically radioactivity is a spontaneous and self-disruptive activity. Spontaneous means लगातार, naturally, without any influence from external forces. Self disruptive activity means itself. So certain heavy nuclei go on emitting radiations like alpha rays, beta rays and gamma rays spontaneously, and this phenomenon of spontaneous emission of radiations by certain radioactive heavy nuclei is known as radioactivity. This is radioactivity is of two types: natural radioactivity and artificial radioactivity. So in this case we are talking about natural radioactivity. Even some artificial sources may also be made. They are used in so many experiments which are forced to emit radiations by some nuclear reactions. So, but naturally some heavy nuclei, some heavy elements, they go on emitting radiations like alpha rays, beta rays and gamma rays, and this spontaneous emission and self-disruptive activity is known as radioactivity. Now, what is the nature of alpha, beta, gamma rays? So what happens? Suppose we take a source of radiation, say radium, in a vessel which has lead blocks and having fine hole, and he put two plates, one positive plate and negative plate. Then experiments show that some radiation pass undeviated, some radiation get deflected at small angles and some towards left, and some get deflected small angles towards right. Means those radiations which are deflected towards left, that is towards the negative plate, it means they are positively charged, they are known as alpha rays. And some rays which are deflected towards the positive plate, it means they are negatively charged, they are called beta rays. And those which go undeflected means they are uncharged, so they are gamma rays. Similarly, when magnetic field is applied in the circle, the same experiment, magnetic field is applied directed normal to the board, directed inward. Then again alpha rays are deflected towards left by small angles, beta rays deflected towards right by small angles, and gamma rays get undeflected, goes undeflected. So it means these are three types of radiations. One is alpha rays which are positively charged, beta rays which are negatively charged, and gamma rays which are neutral radiations. So this direction can be taken by using Fleming's left hand rule. So first finger in direction of magnetic field, central finger direction of motion. For positive charge, thumb will gives the direction of deflection. So it means positively charged particle get deflect towards left. Similarly, negative charged particle will get deflect towards right. So we can find direction by using left hand, Fleming's left hand rule, to find the direction of force. So from this experiment, and we know that there are three types of radiations: alpha rays, beta rays and gamma rays. Now let us discuss some properties of alpha, beta and gamma rays, some important properties. To understand radioactivity topics more, so we must know about radioactivity and the various types of radiations. So first, what are alpha rays? Number one, alpha rays have charge twice that of proton and mass 4 times that of hydrogen atom. Which is nothing but helium nucleus, which is equal to helium nucleus He24. So it means alpha particles are helium nucleus or helium atom which has lost electrons, so it has become charge twice charge upon proton. Now, velocity of these alpha particles is quite large, but it is 1 point less than velocity of light, 1.4 into 10 to the 7 meter per second to 2.1 into 10 to the 7 meter per second, depending upon the nature of source. Third, penetration power of alpha rays is small because of their large mass. So they are heavy, so they cannot penetrate up to large distances. So they can be stopped by thin metal plates. So their penetration power is small. Their penetration power is 1 by 100th times that of beta particles and 1 by 10,000 times that of gamma rays, which is very, very small. Ionization power is large due to their large mass and large velocity. Because they are heavy, they can ionize, they can knock out electrons from atoms of the medium through which they pass. So being heavy and large velocity, so ionization power is alpha particle very large. Range of alpha particles varies from 3 to 8 centimeter in air, depending upon nature of source. So they can go up to 3 to 8 centimeter in air. Produce fluorescence when they are allowed to fall on certain substances like zinc sulfide, barium platinocyanide. So they produce fluorescence, flashes of light. They also affect photograph plates slightly. When they are exposed to photograph plates, they become slightly black. They are affected by electric and magnetic fields, as we have seen from this experiment, because they are positively charged particles, so they are deflected by both electric and magnetic fields. They get scattered through thin metal foils, Rutherford scattering experiments. Most of the particles pass undeviated, undeflected, unscattered through very thin foil, and few of them get deflected at large angles. They are harmful to human body. They produce burns if they are exposed. Our body is exposed to alpha particles, and when they are stopped by some metal surface or when they are stopped, they produce heating effect. So these are the main properties of alpha particles. In comparison, we have beta rays. Instead of positive charge, the beta rays are negatively charged particles. They have charge equal to charge upon electron, mass equal to that of electron. So it means beta particles is nothing but electrons. Velocity of beta particles 33% to 99% that of light. It means their beta particles are faster than that of alpha particles. It means beta particles are nothing but fast moving electrons. Penetration power is large as compared to alpha particles. Due to their small mass, they can penetrate up to more distance as compared to alpha particles. Penetrate 100 times that of alpha particles, you can say. Ionization power is small because they are very light particles, so they are not so strong to knock out electrons to ionize the substance. So their ionization power is small as compared to alpha particles. It is 1/100th that of alpha particles. So range of beta particles is more than alpha particles. In air, it is up to several meters they can go. They also produce fluorescence in substances like zinc sulfide, barium platinocyanide. They also affect photograph plates. The effect is more as compared to alpha particles. They are also deflected by electric and magnetic fields. So these are the main characteristics of beta rays. Gamma rays, they are neutral radiation, no charge. They consist of photons whose rest mass of photon is zero. So because it's energy. So V alpha, their V gamma, velocity of gamma radiation is equal to velocity of light. They can travel with the velocity of light. Their ionization power is small as compared to beta rays and alpha rays. So small ionization power. Uh, then penetration power is very large because gamma rays are have very high velocity. They are very high energetic radiations, so they can knock out electrons. They can penetrate up to more distance as compared to beta and alpha rays. So their penetration power is large. They also produce fluorescence in substance like willemite. They also affect photograph plates, but more than beta particles as well as alpha particles. So there is no deflection due to electric and magnetic field because they are neutral radiations. So they can knock out electron from surface of metal. So that will be photoelectric effect, and they can also cause nuclear reactions. So these are the main characteristics of gamma rays. Now in nutshell, alpha, beta and gamma rays. What is the difference between alpha, beta, gamma rays? Alpha rays are positively charged particle, helium nucleus. Beta rays are electrons. Gamma rays are neutral radiations, have no charge. Penetration power of gamma rays is large than beta rays than gamma rays. In other words, penetration of alpha particle is small, gamma particle is more than beta particle more than alpha particles, gamma particle is more than both alpha and beta particles. Penetration power of gamma is very high, and ionization power of alpha particle is more than beta particles than gamma rays. So these are some characteristics of alpha, beta, gamma rays. So till next video, stay tuned, be happy, all the best, good luck.